Today we are going to talk about some other angles within a circle. So far we have talked about a central angle. A central angle has its vertex at the center of the circle. And we learned that it is the same size as the arc across from it. Then in our last lesson, we learned about inscribed angles. And we learned that inscribed angles are half as big as the arc across from them. Today we're going to learn about some other angles within a circle. They don't have special names, so we won't have any new vocabulary, but we'll just have two theorems that tell us the sizes of these other angles. So our first theorem says the measure of an angle formed by two chords that intersect inside a circle. So a picture of this situation. We are going to have within our circle two chords that intersect. They don't intersect at the center. They're not necessarily perpendicular to each other. They're just two chords that are intersecting somewhere in there. The measure of the angle formed by these chords, so we'll label this angle A. It says the measure of that angle is equal to, so I'll say A is equal to half of the sum means to add, of the measures of the intercepted arcs. The intercepted arcs means the arcs across from them. So the arc right across from A, I'll call X. But then a long time ago, we learned about special angles called vertical angles. So whatever angle A is, that angle that's across from it should be the same thing. And across from that angle, I'll call that arc Y. And this theorem tells us that that angle A and its vertical partner, because they're the same size, will be equal to half the sum of those two arcs. Our second theorem says the measure of an angle formed by two secants, two tangents, or a secant and a tangent drawn from a point outside the circle. So we could have various pictures for this one depending on whether we're going to use secants or tangents. I'll choose to use kind of one of each for our example here, but we'll go through some examples that will show different ways this can look. A secant, remember, is a line that cuts across the circle and goes beyond. So it's like a chord that just keeps going. And I'll use a tangent. Remember, a tangent brushes by the circle and touches it only in exactly one point. I'll call this angle B. Says the measure of this kind of angle is equal to, so I'll say B is equal to half the difference means subtraction, of the two arcs. So there are two arcs that are kind of inside of this angle B. One of them is this far away angle, and one of them is the arc, and one of them is the closer arc. We're always going to do our subtraction in such a way so that we get a positive answer. So always do the bigger one minus the smaller one. So if the angle is formed inside of the circle, but it is not a central angle or an inscribed angle, then that angle is going to be half the sum of the two arcs. If the angle is formed outside, it is going to be half the difference of the two arcs. So those are our two new rules for today, and we'll do some examples here on these. Great. What would I do to find angle 1?
Add 30 and 40.
Add them and then take half of that. So we add them up, we get 70, take half of it, and we get 35. That is the same as an average. Yeah, we're taking the average of the two angles. So we get angle 1 is 35 then. Angle 2 is formed outside of the circle by two secants. What's our rule for outside? We do the difference, which is a subtraction, and we're going to do half of that. So we want to subtract these two, subtract them in such a way that you get a positive answer. So we're going to do 120 minus 40, which is 80, and half of 80 is 40. It happens to be the closer arc in this one, but that doesn't work. Okay, so don't just take that closer number. It is half the difference. So we're going to subtract those two arcs and then take half of that.
It doesn't matter like which you subtract, it's just the higher one that you subtract.
Yeah, we just want to do bigger minus smaller so we get a positive answer. What would we do to find angle 3 here? We need the calculator. Okay, it doesn't work out evenly. What do we need to do?
275 divided by 2.
Add them up and divide by 2, so we get 275 divided by 2, which is 137.5. Okay. For an angle inside, our rule is half the sum. So we add the two arcs across from our angle, and we divide by 2. Angle 4 is outside of our circle, formed by two tangents. But no matter what kind of things are forming it, secants or tangents, our rule is when it's outside of the circle to do half of the difference of the two arcs. Only one arc is labeled here. Just the 260 is labeled. So we need to know what the other arc is. How do we find that? 360 minus the arc that we know would give us the other arc. So that other arc must be 100, so that our whole circle has a 360. Then our rule is half the difference. So we're going to subtract those so that we get a positive answer. So 260 minus 100 is 160, and we want half of that, which would be 80. All right, this one's formed outside by a secant and a tangent. So our rule is half the difference of the two arcs. But it is half the difference of the two arcs that are kind of within the angle. We don't know those. So what is the missing arc here? Yeah, what is going to be that missing arc that's across from the 5? How would we find that?
80.
It's going to be 80. How do we find it?
Add the other two and subtract from 360.
Yep, so we can see so far we've used up 280 degrees of the circle. So we can subtract that out. There must be 80 more degrees within the circle. The whole circle has to be 360. Now that we know that missing arc, our rule is half the difference. So we subtract, and we get 80, and half of that is 40. What rule are we going to apply here? The difference. It's an outside angle, so we're going to do half the difference. And what do we get? 90 is the difference. What do we get for our angle? 45. So I'm going to subtract them in such a way we get a positive answer. So 170 minus 80, we give 90, and we want half of that for our angle. In this one, we want to find x. So our angle is inside of the circle. What is our rule for an angle inside the circle? It's going to be vertical with the other one across from it. How do we find it? I mean, we know it's 75 here, but what was our rule about an angle inside the circle?
It's equal to half the sum of
It's equal to half the sum of the arcs, and we're looking for one of the arcs on this one. So this is like our very first example problem, except our unknown is in a different place. We're not looking for the angle, we're looking for an arc. To do this, we'll need to set up a little algebra equation. Using that same rule and formula as before, that an angle, which we know is 75, is equal to half of the sum of the arcs. So it is 50. Yep. Some of you will be able to kind of look at them and figure it out. Sometimes they aren't going to turn out to be such nice numbers, so then you might actually need to do a little bit of algebra to work its way through. There's two ways to solve this problem algebraically. One way is to distribute the 1/2 through, and that's a totally fine way to do it. What I like to do is get rid of the 1/2. And the way that I get rid of 1/2 is by multiplying both sides of the equation by 2, because 2 times 1/2 will cancel. So we get 150 equals 100 plus x, and we get 50 as our answer then. So we use the same rule that we applied before, it's just that our unknown is in a different place. So the angle we know is equal to half the sum of the arcs, and one of those we don't know. This angle is outside, so what is our rule there?
difference.
Half the difference. So our angle, which we know, is equal to half of the difference, or the subtraction. Subtract the bigger one minus the smaller one. The further away it is, the bigger it's going to be. So we're going to do x minus 70. If you get a negative answer, it just means that you accidentally subtracted them backwards. Right? So you just want to make sure that you're going to get a positive answer for this. If you get a negative, you just subtracted them backwards. Once again, to solve, I'm going to multiply both sides by 2 because that will cancel out that half. And I get 60 is x minus 70. And if I add 70 to both sides then, I get 130 is that missing arc. Questions? I have one more example, and I tried to conserve space, but I kind of ran out of room. So I'll flip over for that next one. But are any questions before I erase these?
Why is it 130? Wait.
So our rule for an angle outside is that the angle is equal to half of the difference. So we want to do that missing arc x minus the 70. Multiply both sides by 2 and I get the 60, and then when I add that, 60 and 70 makes 130. And you can double check it back like the previous problems before if we were more comfortable with the previous type of problem and say, if I do 130 minus 70, I get 60 and half of that does give me 30. So I can double check it back that it does follow the rule the way we did the first group of problems. class when we have two tangents, we've got an angle outside. Our rule for an angle outside is that the angle is equal to half of the difference of the two arcs. The close arc is x. How big is the other arc?
360 minus x.
360 minus x. The whole circle has to be 360, so if x is one part of it, then 360 minus x is the rest of it. To solve this, I'm going to solve it like I have the other one. So I'm going to multiply both sides by 2 because that cancels out that half. So I get 116 is equal to 360, and I can put together those x's. One x and another x makes two x's. Then I would subtract 360 from both sides. Gives negative 244. And divide by negative 2. Gives 122. I always like to kind of double check my work and think through this problem again once I think I know the answer and say, okay, if this is 122, then the rest of the circle would be how much? 360 minus 122, which is
238. 238.
Is it 138? 238? 238?
It's 238.
Okay. And then think through, okay, half of the difference of that, if I subtract that, divide it by 2, do I get what I'm supposed to get? Right? Since I'm more comfortable kind of working the rules that way than the algebra way, once I get my answer, I like to check it and make sure that it does work out with the way that we did our first group of problems.
That was hard.
Yep.
A lot of times, yeah.
A lot of times they get harder as you go because you have to start doing some algebra and not just being given the arcs. You'll need to find the arcs. For your assignment, you're going to do 1 to 21 from section 6. Now, a note on your first 10 questions here. The first 10 questions all use the same diagram and build from each other, but you don't necessarily need to find them in order. So if you're working through and you can do number 1, you find that, you find number 2, but you can't really figure out what you're supposed to do for number 3, that doesn't mean you have to stop on the whole thing, okay? Look for other information, and maybe once you find something else, you'll be able to work your way back to number 3. They all build off each other. I would strongly suggest redrawing the picture on your homework so you can label things as you go. Since they're all building from each other, it would be helpful to label in answers once you think you know them, okay? Or, if you're using pencil and only pencil, you may lightly just write it in your book, if you please erase as soon as you're done. Now, other people may have not listened as carefully to my instructions, and there may be markings in your book. I would suggest that you don't trust them and that you just erase it and begin again. So you may mark in your book if you do so lightly, and please erase as soon as you're done with that group of problems. But again, you don't necessarily have to find them in order, so if you get stuck on one, don't just give up on that whole group. Go and look for some other ones and see if you could work your way back to it.